Today we discuss about bond parameters. Bond parameters or is also known as bond characteristics or the properties of a bond. Okay, so we know that different bonds are present, covalent bond, ionic bond, and different molecules they are present between different atoms. So every bond, any bond have some characters, some characteristic properties of bonds. The important of them are, for a bond the main property is main its characteristic is bond length. Means so we are discussing the properties of the bonds which are measurable. Okay, which are measurable properties of the bonds, that is bond length. It is also known as bond distance. Okay, bond length is also known as bond distance. Next, bond strength. Okay, it's also known as bond energy. Bond energy. So every bond has some strength, that is called bond energy or bond strength. Is also known as bond dissociation energy. It is also known as bond dissociation energy. There is one more important property there regarding bonds is bond angle. Is bond angle. Okay, so these are the three main parameters, three main characteristic properties of a bond. In these, most important are bond length, bond energy. Okay, now we discuss each and every one in detail. First, so write it. First we see about bond length. That is nothing but bond distance. First simply we discuss, I will explain about the bond length. Okay, just listen. So bond length mean, so itself it is in the name, that is bond length, nothing but a length of a bond. So length of how you treat it as a, which is treated as a bond length means, for example, two atoms are there, for example say X and Y. X and Y are covalently bonded and covalently bonded. So this is the nucleus of one atom, this is the nucleus of one atom. So that distance between the nuclei of two bonded atoms, the nuclei of two bonded atoms, the distance is called bond length or bond distance. Generally covalent bond అయితే మనకు overlap అవుతుంది. That's why I written like this. Okay, the distance between the nuclei of two bonded atoms is called bond distance. Okay, so means in the covalent compounds we can write, for a covalent compound you can write, see this length is radius of X and radius of Y. So generally in atomic radius we discussed that what is the covalent radius. For example, this is the covalent bond, this is distance between the nucleus, the half is treated as the covalent radius. Just remember it, covalent radius. Okay, this is radius of one atom, this is radius of another atom. So by combining these two we will get that distance between the two nucleus. nuclei. Means simply we can define the distance between the nuclei of two bonded atoms. A covalent bond lo otenemo the bond distance, okay, bond length equal, we can write radius of two bonded atoms. For example, ఇక్కడ x and y తీసుకుందాం. Okay, radius of x plus radius of y. Okay, two atoms తీసుకుంటే xy atom తీసుకుందాం, xy molecule తీసుకుందాం. For example, if you take ionic compound or if you take ionic bond, so ionic bond తీసుకుంటే what is the bond length? So ionic compounds, ions are present, ions are close together. Then the radius of cation plus radius of anion is treated as the bond length. Okay, so this is the definition of bond length. Okay, now we see some other points in bond length. So for covalent bond kitnemo two దీని radius two bond అయిన two atoms radius add చేస్తే that is the radius of that that is the bond length of that bond. అది ionic bond అయితే the bond length is equal to radius of cation and radius of anion. Okay, now we see some more points regarding bond length. See, if bond length is inversely proportional to the number of bonds, is inversely proportional to number of bonds. For example, between two atoms, I am taking the carbon atoms, okay, as example. Between say here, so carbon ki compulsory 4 bonds treat cheyali kabatti so I am writing this, but we need to know about this part. So in the first there is triple bond is present, here double bond, here single bond is present. So the triple bond, 3 bonds automatically they are somewhat close. Okay, already we discussed this thing in VSCPR theory. So here generally bond length is 1.20 angstrom. ಅದಕ್ಕೆ ಡಬಲ್ ಬಾಂಡ್ లో it is 1.34 angstrom, here it is 1.54 angstrom. means ఇక్కడ 2 carbon bonding, here also 2 carbon bonding, here also 2 carbon bonding, but here the single bond is present, here double bond, here triple bond. Means as the number of bonds increases, bond length decreases between the two atoms. అంటే ఇక్కడ కంపారిజన్ లో సేమ్ atoms comparison చూడాలి మనం. Okay, CC bond we are discussing about now, example as CC bond. C single bond, C 1.54 angstrom or 154 picometers. C double bond, C 1.34 angstroms. C triple bond, C 120 picometer angstrom. So it can be written as picometers at exactly close to 134 picometers, it is 154 picometers. Means these are the small units, angstroms, picometers, nanometers, they are small units. We can't use the centimeters, meters for length. The general length it is okay, but here the bond distance means they are very small. They are very small, but generally the units for bond length are the units used for bond length. Generally used units are angstroms, nanometers, picometers. So 1 angstrom equal how many centimeters? 10 power minus 8 centimeters. So what is 1 nanometer? 10 power minus 9 meters. So what about 1 picometer? 10 power minus 12 meters. Okay, means they are the bond distance generally very small value kabatti they are represented in small units. Okay, next, bond length is also depends on hybridization. It also depends on hybridization. So how it depends on hybridization means so here for example, so bond length depends on hybridization. Actually, you can say the bond length is directly proportional to, okay, bond length directly proportional to S character. More S character, bond length is less. Sorry, it is inversely proportional to S character. Okay, so S character general గా దేంట్లో కంపేర్ చేస్తే హైబ్రిడ్ ఆర్బిట్ ఆల్సో మనకి S character ఫైండ్ అవుట్ చేస్తాం. ఓకే, ఇప్పుడు ఫర్ ఎగ్జాంపుల్ టేక్ C bond H in C2H6. C2H6 means we know the structure C2H6 ethane. So what is the name of this compound? Ethane. Then what ethene? So all these molecules. Then what about ethyne? Okay, ethyne. So then all are having C, but now I am discussing about C bond H. C bond H length discuss chedam. Here C bond H length is different in different compounds. Even it is present in even there is a presence of same bond, CH bond covalent bond, CH covalent bond, CH covalent bond. But the bond distance is different in different molecules. In these molecules is totally different. Already we discussed about the single bond, double bond, triple bond. It's a different thing. Now I am discussing about the single bond between the CH. So అన్నిట్లో సింగిల్ బాండ్ మనం డిస్కస్ చేస్తున్నాం. బట్ దిస్ సింగిల్ బాండ్ ఇక్కడ ఉన్న CH లో ఈథేన్ లో the CH bond length is how much is given as this is experimental value. Directly we can't calculate it. That is approximately 1.112 angstroms. In ethene, that is 1.103. Next, ethyne is a triple bond. So where the triple bond is present, that is a 1.08. Means so what is the difference? Why there is a difference in the C bond H means due to the change in S character. Okay, so here the S character in sp3 already we know what is the hybridization of this carbon. sp3 hybridization, this carbon sp2 hybridization, this is sp hybridization. So here what is the S character? 25%. Here what is the S character? 33.3%. What is the S character? 50%. See the here same CH bond. Here what is the overlapping? What is the overlapping? sp3 yes. Here sp2 yes. Here also sps. Hydrogen common s orbital. So here bond length is 1.112. Here just 1.103. It is just 1.08 angstroms. Means as S character increasing, bond length decreased. For the same bond in different molecule, the bond length is different. It is happened due to the difference in the S character of that particular atom. Here sp3 undi, ఇక్కడ 25% S character. Here sp2 33.3% character. Here sp లో 50% S character. So actually electronegativity proportional to S character. There is one relation is there. Electronegativity proportional to S character. Means S character ఎక్కువ ఉంటే దానికి అట్రాక్టింగ్ పవర్ ఎక్కువ ఉంటుంది. As S percentage increases, its attractive nature is increases. So attractive nature increase అయిందంటే so they become somewhat closer. So ఇక్కడ S character 50 ఉంది కాబట్టి సో ఈ 50% ఎక్కువ అట్రాక్ట్ చేస్తారు H తో ఉన్న బాండ్ ని. సో therefore so attracting power increase అయిందంటే the length will be decreases. Therefore as its character increases, bond length decreases. Okay, so this is one of the factors. Okay, hybridization is the one of the factor. So now we observe electronegativity also one of the factors. Next, bond length is also depends on resonance. So actually this topic was not completed. So it also depends on resonance. So resonance means having more than one structure for a single molecule. ఒక సింగిల్ మాలిక్యూల్ కి మోర్ దెన్ వన్ స్ట్రక్చర్స్ ఉన్నప్పుడు ఆటోమేటిక్ గా బాండ్ లెంత్ చేంజ్ అవుతుంది. హౌ ఇట్ ఈస్ యాక్చువల్లీ దిస్ ఈస్ సపరేట్ టాపిక్ ఈస్ దట్, బట్ జస్ట్ వి గివ్ ద ఇంట్రడక్షన్ ఫర్ ఇట్. ఓకే, so you know benzene. What is the benzene formula? Can you guess the what is benzene? Can you remember the benzene formula? C6H6. So it is like this. These center points మొత్తం మనకి కార్బన్. ఓకే, these center points are carbon atoms. Now see the between the two carbon atoms. So here which bond is present? Double bond is present. Here which bond is present? Single bond is present. So ఇక్కడ రెండు ఉన్నాయి కార్బనే. ఈ పార్ట్ ఒకటి మనం ఇక్కడ ఇండికేట్ చేస్తున్నాం. C double bond C. నెక్స్ట్ ఈ కార్బన్ కూడా H ఉంది. సో ఈ కార్బన్ ఇక్కడ సింగిల్ బాండ్ ఉంది. ఇట్ ఇస్ హావ్ సమ్ H. ఇట్స్ ఓకే. అయితే see here C double bond C, what is the general bond angle? 1.34 angstroms. What is the single bond? Here double bond length is 1.34 angstroms. The single bond length is 1.54 angstroms. This is experimental evidence. But in benzene there is no 1.34. There is no 1.54. So ఈ సింగిల్ బాండ్ ఉన్న ప్లేస్ లో 1.54 లేదు. ఈ కార్బన్ డబుల్ బాండ్ ప్లేస్ లో 1.34 లేదు. ఇట్ ఈస్ హ్యావింగ్ all bond lengths equal. And ఎన్ని బాండ్స్ మనకి కార్బన్స్ కి 1 2 3 4 5 6 కార్బన్ బాండ్స్ ఉన్నాయి. సో all are having 1.39 angstroms. Means it is greater than double bond. 1.34 కంటే డబుల్ బాండ్ కంటే హైయెస్ట్ ఉంది. సో it is less than single bond. సింగిల్ బాండ్ ప్లేస్ లో 1.54 ఉండాలి. But all 6 bonds are having same bond length, that is 1.39 angstrom. సో ఎక్కడ లెంత్ చూసినా 1.39 angstromనే ఉంది. అది ఇక్కడ డబుల్ బాండ్ ఉన్నప్పుడు 1.34 ఉండాలి, సింగిల్ బాండ్ ఉన్నప్పుడు 1.54 ఉండాలి. బట్ ఇట్ ఈస్ నాట్ experimentally proved. It is proved that in experimentally that all carbon bonds are having exactly same identical bond length, that is 1.39 angstroms. So how it is possible means so the reason given for it is benzene undergoes resonance. Resonance means benzene does not present in a single structure. So benzene like present like this. Benzene also present like this. Okay, మన కార్బన్ రిప్రజెంట్ చేయట్లేదు. సో జస్ట్ ఇక్కడ డబుల్ బాండ్. సి హియర్ డబుల్ బాండ్ ఈస్ ప్రెసెంట్. సో ఇదే బాండ్ ఇక్కడ ఎలా ఉంది? సింగిల్ బాండ్. సో హియర్ దిస్ బాండ్ ఈస్ డబుల్ బాండ్, హియర్ ఇట్ ఈస్ సింగిల్ బాండ్. సో దిస్ ఈస్ డబుల్ బాండ్, హియర్ ఇట్ ఈస్ సింగిల్ బాండ్. మీన్స్ ద షిఫ్టింగ్ ఆఫ్ డబుల్ బాండ్స్ టేక్స్ ప్లేస్. ఇక్కడ డబుల్ బాండ్స్ ఏంటంటే షిఫ్ట్ అయిపోయినాయి. మన జనరల్ మన డిఫరెన్స్ బిట్వీన్ ద సిగ్మా బాండ్ పై బాండ్ ఎలక్ట్రాన్ పై బాండింగ్ లో రాస్తాం. సిగ్మా బాండ్స్ ఆర్ నాట్ మొబైల్ ఎలక్ట్రాన్స్, దే ఆర్ లోకలైజ్డ్ ఎలక్ట్రాన్స్ అంటాం. అదే పై బాండ్ లో ఎలక్ట్రాన్స్ ఆర్ కాల్డ్ డీలోకలైజ్డ్ ఎలక్ట్రాన్స్. డీలోకలైజ్డ్ ఎలక్ట్రాన్స్ ఆర్ మొబైల్ ఎలక్ట్రాన్స్ అంటాం. ఓకే, సో ఈ పై ఎలక్ట్రాన్స్ మూవ్ అవుతా ఉంటాయి. ఇక్కడ డబుల్ బాండ్స్, ఇక్కడ ఇట్ ఈస్ నాట్ ఏ పర్మనెంట్ డబుల్ బాండ్. it is not a permanent single bond. ఇది పర్మనెంట్ డబుల్ బాండ్ కాదు, ఇది పర్మనెంట్ సింగిల్ బాండ్ కాదు. కాబట్టి 1.34 లేదు, 1.54 లేదు. ఇట్ ఈస్ బిట్వీన్ those two values, that is 1.39 angstroms. Why it happened? For example, only one shape, one structure ఉంది. ఈ వన్ స్ట్రక్చర్ ఉన్న ప్లేస్లో అప్పుడు డబుల్ బాండ్ దగ్గర 1.34 ఉండేది, సింగిల్ బాండ్ ప్లేస్లో 1.54 ఉండేది. బట్ డ్యూ టు ద ప్రెసెన్స్ ఆఫ్ దిస్ టూ స్ట్రక్చర్ ఫర్ బెంజీన్, the bond length is become 1.39 angstroms. Means now we got the point that bond length is also depends on resonance. Resonance అంటే ఇది మనకి one molecule two structure తో represent చేస్తే one molecule, if a molecule is represented in more than one structure, if a molecule is represented in more than one structures, that is called resonance. Due to resonance, what is happening? There is a change in the bond length takes place. Okay, this is one of the best examples for resonance. So next, so how the bond length is calculated experimentally. So bond length, just now we said it is very small value. So bond length is a very small value. So ఈ వెరీ స్మాల్ వాల్యూ మనం ఎట్లా ఐడెంటిఫై చేస్తాం, ఎక్స్పెరిమెంటల్గా ఎట్లా ఐడెంటిఫై చేస్తామంటే there is some specific methods are there to determine this bond length experimentally. So what are the methods? So what are the methods to calculate the bond length is there is X-rays diffraction method, X-rays diffraction method. Next, electron diffraction method. Generally, X-ray diffraction used for solid substances. Electron diffraction method used for gaseous substances. There is one more method is there that is used for solids and also gases. That is a spectroscopic method. Okay, these are methods, these are the techniques used experimentally to determine the bond lengths of different bonds. Next, one more important thing is, so afterwards I give the notes clearly. Okay, first we need to understand carefully about this topic. For example, they see bond energy. Okay, afterwards we give the examples. So this was about bond length. Now we give the notes. So take the notes perfectly. Take the notes perfectly. It's a very important one. So some more points are there. Here it is ionic bond. Okay. You can see the example, so in which the bond length is depends on hybridization. Here the CH bond length in every sentence, that is a C bond H is there, but here it is in alkanes, ethane, alkenes, ethene, alkynes, ethynes. Here sp3, sp2, sp. So as a hybridization changes, the bond length is also changes. So how hybridization changes the bond length means, so because here it totally depends on S character. So hybridization depends on the hybridization, nothing but implies S character. So hybridization lo S character danni affect chestadi. So we can say the bond length is inversely proportional to S percentage. Okay, and we can say actually electronegativity of that carbon is directly proportional to S percentage. And S percentage increase होते electron negativity increases. Electron negativity increase means attraction power increases. Attraction power increase and then they come close together, therefore bond length decreases. Here in sp3 we know that sp3, so what is the S character? There is only 25%. In sp2, what is the S character? Approximately 33.33%. In sp, what is the S character? So write them. So 50%. So 50% is more electronegativity, more attraction power, S percent increases and the bond length decreases. So very small variations or takes place due to the S character. Means here we, in this example we got the effect of S percent, nothing but electronegativity, and also hybridization. So here we see, so one more factor already we discussed, that the bond length is inversely proportional to number of bonds between the two atoms. Only two atoms ki compare chestam. So for example, if a triple bond is present between the two carbon atoms, if double bond is present between two carbon atoms, if a single bond is present between the two carbon atoms. Okay, so what is the bond length of these two carbon atoms? So this is here the carbon, this length is so 1.20 angstrom. So it is less than. This is 1.34 angstroms. This is less than 1.54 angstroms. Okay, means the bond length means they are having the triple bonds. Triple bonds having less than double bonds. This higher one is the single bond between two atoms. So different atoms ki compare cheyadu between two atoms. For example, ఇక్కడ CC కంపేర్ చేసి అన్నిట్లో CCనే కంపేర్ చేయాలి. ఓకే, CH అయితే CHA కంపేర్ చేయాలి. ఓకే, లైక్ దట్. సో these are the main points about bond length. So the one more property is there. So here one more point, the bond length of polar bond is smaller than the non-polar bond length. So ikkada polar means so electronegativity is less. So non-polar means so polar character means electronegativity difference is more electronegativity difference. That's why it becomes more attraction and becomes smaller. Okay, so we can say, so polar molecules, polar bond ఎప్పుడు ఫామ్ అవుతుంది మనకి, టూ డిఫరెంట్ ఎలక్ట్రోనెగటివిటీస్ ఉన్నప్పుడు పోలార్ బాండ్ ఫామ్ అవుతుంది. సో ఎలక్ట్రోనెగటివిటీ డిఫరెన్స్ మోర్ ఉన్నప్పుడు దెర్ ఇస్ మోర్ అట్రాక్షన్. దట్స్ వై there is a bond length is smaller when compared to the non-polar bonds. Here one more important thing, the examples. So these examples not related this point. These are the general example for bond length topic. So there is no need to by heart these examples. There is no need to by heart these examples. So why we given these examples means to compare that see this example chlorine, this is fluorine, chlorine, bromine, iodine. Actually these are the halogens belongs to same group. So in which group they belong? They belongs to which group in periodic table? 17th group. So what is the order? Fluorine, chlorine, bromine, iodine. So this is the 17th group, halogens. And in atomic structure we said that the size from top to bottom increases. In the same way, here see fluorines smaller, 2f smaller, but it is just 1.42. It has come down, comes to the down. That's a chlorine, 1.42 to 1.99. Then comes to the bromine, it is 2.28. Then comes to the iodine, it is a bigger in size. 2 iodines connected, that is a higher one, that is 2.67. It is total in the increasing order. Okay, their size increases means their bond length also increases if the bond present between them. Here also we can observe one more thing, that is HF, HCl, HP or HI. So already we know that fluorine size is smaller. H size is common. Fluorine size is less than chlorine, chlorine less than bromine, bromine less than iodine. Okay, so as size I size increase but bond length increase. That is the one property. Let's include in the tag. Here we can say as the polarity increases, bond length decreases. Polarity means the difference in the electronegativity. Difference in the electronegativity. Here HF, F is the electronegativity first position. So electronegativity difference is ఎక్కువ. So వీటన్నిటిలో ఈ 4 compounds which is more polar, this is more polar. Which is less polar, least polar. So this is the least polar. So this is the highest polar having smaller. So that is just 0.92. It is bond length is 1.61. Means non-polars having the more bond length compared to the polar. Okay. So this is about bond length. Next tomorrow in next class we see about the bond angle and bond energy. Okay.